Let's take a look. Let's take a look at this review problem number 29, and it gives us this equation, and it asks us to list the intercepts, and then I'm adding to write the domain interval notation and write the range in interval notation. So let's look at the first one first. List the intercepts. Well, first of all, let's remember, if we want to know what the intercept is on the y-axis, that's where x is going to be equal to 0. So let's take a look at our equation here, and if we set x equal to 0, well, immediately we have a big problem, because we have 5x to the fourth. That would give us a 0 denominator. So there are, in terms of y-intercepts, none. And when we want to have an x-intercept, you look on the x-axis, and that is where y is equal to 0. So let's set y is equal to 0. So we want to go 0 is equal to x squared minus 25 over 5x to the fourth. Now, one thing I could do if I wanted to do this all formally was I could multiply both sides of this equation by 5x to the fourth, and that would eliminate it from the denominator over here, and anything times 0 would be 0 over here. So I would be left with 0 is equal to x squared minus 25. But I don't really even need to do that multiplication, because I know that 0 divided by anything is going to be equal to 0. So I really know that if I can make my x squared minus 25 equal to 0, as long as x is not equal to 0, because we know that that's excluded over here, then I will have my y-intercepts. Well, x squared minus 25 looks suspiciously like the difference of two perfect squares, which means it should be x plus 5 times x minus 5 equals 0. So that means x should equal plus or minus 5. That would give me my two intercepts, and if I write them properly in point form, that would be 5, 0 and negative 5, 0. So that's the answer to the first part. I'm going to come over here and I'm going to clone this page, and I'm going to clear all the ink off, and I think I'm also going to get rid of this graph. Let's delete that. Have a little more room there. Now I want to talk about the domain in an interval notation. Well, there's a couple of things I'm looking at here. One is that I know that x, oops, let's get a pen. I know that x equals 0 is going to be excluded from the domain. It's hard to write on this little tablet. It looks kind of childish, but I think you can read it, especially since I've said it. And I also know that my parent function here is x squared. And really, if I eliminated this 5x to the fourth, I would say that my x squared minus 25 looks like it is pretty much a function of the parabola x squared, lowered beneath the x-axis by 25 units. But so I'm thinking that I should have a domain of negative infinity to infinity if it's just an x squared parabola. But this denominator is throwing me a little bit, and I'd really like to be sure, and I know that 0 is excluded. So what I did was I plugged it into my TI calculator. You can see the formula right here, and you can see that I used parentheses very liberally so I know exactly what's going on. And I'm going to go, I'm going to graph it. So I'm going to go zoom 6. And my graph looks very strange. Well, it looks like kind of like an upside down parabola that's been split in the middle. I'd say it's pretty clear. Well, I'd say nothing is pretty clear. So I'm going to change my window a little bit just to see what these two things look like. This as it approaches the x-axis on both sides. So I'm going to set my window. X is equal to -3, the minimum, and I'm going to go over here to +3 and leave my x scale at that. I'll leave my y scale at 10, -10 for the time being, and I'm going to graph it. So I get a little bit better picture of what it looks like as it's approaching my x-axis. And what I'm going to do is I'm going to use the trace function. And you can see that the trace function says that x equals 0. Well, that's way down here someplace. I don't know where that is. So I'm going to just go left on my trace, and I'm going to go a bunch until I can see my little cursor. Oh, there's my cursor. And I'm going to keep going left here. As you can see, my cursor is going left, and my x values are getting smaller and smaller. And my y values are getting smaller and smaller. But as my x values get smaller and smaller and my y values get smaller and smaller, it looks to me as if my y values are never going to hit 0. They're just going to get smaller and smaller and smaller as x gets smaller and smaller and smaller. So that makes a lot of sense to me. In other words, I have an asymptote so that where on my x-axis. So what I'm going to do then is I'm going to say, well, what I'm going to do is I'm going to do a couple things. One thing I'm going to do right now is I'm going to evaluate this function for an x value. So I'm going to go second calc, and I want to know my value, which will be my y value, and I'm going to go at x is equal to 100. So I'm going pretty far out to the right here to see what my value would be. And I'm going to go enter. Up. It told me I didn't like it. Why not? I want to evaluate my function. Well, I'll do it a different way. I will go alpha f4 y1. So that's my function, and I'm going to evaluate it for x is equal to 100. I'm going to close my parentheses. And I can see that, again, I have a very, very, very small y value, but it has not reached 0. So what this is telling me is that my domain get a pen. My domain is parentheses negative infinity comma 0 union, whoops, not a u, it's a u like that, union 0 comma infinity. And let's just check that one more time to make sure that I don't have any value. Let's make my x value really, really small. So I want to go alpha f4 y1, and I'm going to evaluate this for x is equal to 0.00005. So very, very tiny x value. And let's see what I come up. I come up with a 0. What I come up. So I come up with a very, very large y value. Way, way, way down low on the graph, but it is not hitting. Again, it's not hitting the. It's not hitting 0. So I think this is a pretty safe domain. And if that is my domain, then what would my range be? Well, if I kind of again look at my graph, my range is going to be way down here, negative infinity, And it looks like it's going to come up, and we know it's not touching the 0 because we already tested out that value. So my range will be, again, need a pen. My range will be negative infinity to 0. But no union, because that's as far as it goes. My y values, my range, are going to range all the way from negative infinity, and they're going to come almost up to 0, but they're never going to touch it. So that would be the answer to this question.